Have you ever been puzzled by unexpected behavior in your code? It can be incredibly frustrating, especially when you think you understand how things should work. If that sounds familiar, you're in the right place. Today, we're diving into a peculiar case where a method call acts unexpectedly like an L value. I totally get it. You write your code and everything seems fine until you hit a snag that leaves you scratching your head. You're not alone in this. Many developers encounter similar issues, and it can be a real brain teaser. Let's take a closer look at the specific question that sparked this discussion. One user asked, "Why does this code compile when I expect an error about L values?" They provided a code snippet where a method call seems to behave like an L value, which is definitely intriguing. Sound familiar? Let's explore this together. So, what's going on here? The user expected an error when trying to assign a value to the result of a method call, but the code compiled without any issues. This can be confusing, especially when the same code behaves differently with a slight change. Let's break it down. And stick around. At the end of this video, I'll share a key insight that could save you from similar headaches in the future. To understand why the code compiles without errors, let's first clarify what an L value is. An L value refers to an expression that points to a memory location and allows us to take the address of that location. In the user's code, the method getBar returns a foo object. However, since foo is defined as a typedef for long, the returned object is treated differently than expected. When the user calls fgetBar, it returns a temporary object. In C++, temporary objects can be treated as L values in certain contexts, which is why the assignment to M2 does not produce an error. If the user changes the typedef from long to long, the behavior changes because long is a fundamental type, and the temporary object cannot be assigned to directly, resulting in the expected error. In summary, the unexpected behavior arises from how C++ treats temporary objects in relation to L values. Understanding this distinction can help the user avoid similar confusion in the future. Fun fact, did you know that C++ allows you to return references from functions? This can lead to some powerful programming techniques, but it also requires careful handling to avoid unexpected behavior. Now let's look at the answers provided by other users. This user explains that using operators on class-type objects involves calling a function, which is known as operator overloading. Since it's permissible to call functions on R values, there's no compilation error in this case. They note that while you can prevent the overloaded assignment operator from being called on an R value, the class designer chose not to do that. That's it for that response. Let's explore another one. The user clarifies that the expectation of an error when assigning to f.getBar is incorrect. They explain that this rule applies only to built-in types. In C++, an R value of class type can modify its referent under certain conditions, such as when a member function is called. Now, let's see a response from a different user. An alternative solution provided by another user suggests qualifying the return type of the getBar method with const. This way, you cannot assign values to const objects, which will cause the compiler to raise an error. Here's the insight I promised. Always be mindful of whether your methods return values or references. This small detail can save you from a lot of confusion and unexpected behavior in your code. And there you have it. Understanding how method calls work in C++ can prevent unexpected surprises. If you found this video helpful, please hit the subscribe button for more coding tips and tricks. And remember, the more you know, the better your coding experience will be.